you would need these formulas. This is 13, 14, 15, and 16 are all from 8.5. So kind of keep that in mind. There are work problems and there are rate problems. And these would be the general formulas you would need for those types of problems.
So this would be like the setup.
Right.
So we write that down on our...
I would. Now keep in mind this rate problem, the x and the x plus number, those can interchange. It could be like the x plus number could be up here, the x could be down here. That's not a big deal. And when you read it, it should be pretty simple. But yeah, make sure you get these down for your note sheet. That would be perfect because those are help you set up. X plus the 4.3 will represent the first one, right? Now, the t is always the d divided by the r. So this 9 divided by x plus 4.38 and x 8 divided by x. All that is so that you can set up a cross multiply problem because they travel the same time. So set those equal to each other and cross multiply. That's all that's going to come down to. I mean, if you can do that without having to set up the box, then you do that. So all I've done is cross multiply. 9 times x is 9x, 8 times x is 8x, 8 times 4.38 is 35.04. Subtract, move the 8x over, and you get x is equal to 35.04. That's how fast the second skater went. So that means the first skater went 4.38 faster, so I would add 4.38 to the 35.04 and have the first skater's speed. That's it for that problem. I'm just pausing contact. Okay, so again, here I did, again, the 1.5 is together, the 2 is by the class blur by himself, x is what I'm looking for, and then yes, cross multiply, 1.5 times x is 1.5x. 2 times 1.5 is 3. But also keep in mind that 2 and the x need to multiply the 1. So just put them together. 2 times x is 2x, times 1 is 2x. Okay. Then it's a simple solve. Subtract, then divide. Yes, the 1 will turn into 2x because you're getting rid of these fractions. So you're multiplying by the 2 and the x, least common denominator. So
multiply that 2 times x
and to the 1. Mm-hmm. Okay, now subtract 2 minus 1.5 is 0.5, and then divide by 0.5, and you get your answer is 6. So the apprentice by himself would take 6 hours. So you want to get rid of the fractions. To do that, you find the least common denominator. Now, what I do is this. You see an x? Go ahead and write that you're going to need an x. Oops, I should have just written just an x. Let me try that again. Okay, so you see an x, you're just going to write that you need an x. Write the x. Okay, then look at the next denominator, next fraction. Got a 3, so write a 3. They're completely different. Then you look at the last one, and you already have 3x here and you have 3x there. So do you need to add anything to that? No. So this right here will represent your least common denominator. So now what that means is you're going to multiply all 3 of those fractions by 3x. And
top and bottom, right?
Top and bottom. Well, this is the way I look at it. I write it like this, and then something with the bottom and that 3x will cancel out, leaving me no fraction. Whatever's left over will multiply the numerator. So like in the first fraction, what cancels out?
The x.
The x's, leaving me 3 times 4, which is
12.
12. The second fraction, the 3's cancel, leaving me x times 2, which is 2x. The last fraction, 3x cancels 3x, so I'm left with a 6. I would have moved the 12 over and then divided by 2, but that's just me. It doesn't matter. I mean, you could have moved the 6 over, but you have to move the 2x over to the other side. Because otherwise you could end up with a sign error. But your answer there should be -3.
Can you move
Okay, let's look at 14. Okay. You notice that they both have an x, or or at least 2 of them have an x. So you see an x, I'll write down an x. Now, here's the thing that you got to be careful of. You got a 4, a 2, and an 8. Always go with the higher number, the bigger number, because you're looking for something that all 3 can divide into. So the biggest number here is 8. Is 8 divisible by 4? Is 8 divisible by 2?
Yes.
So that's the number I'm going to work with.
It doesn't matter if they don't have an x.
Doesn't matter if they don't have an x. We're just trying to find the least common, because we're worrying about the dividing part in a minute. Okay, now, you look here, in the first fraction, what cancels out?
The x's.
The x's. Now, what's 8 divided by 4?
2.
2 times 7?
14.
14. Here, the next one, the x's cancel out again. 8 divided by 2
It's 4.
is 4, and
I'm obvious.
hold a second.
14
Right.
minus 4 equals 5x.
Right. Okay, and the 8's cancel out, leaving you x times 5, which would be 5x. So 14 minus 4 is 5x. 14 minus 4 is 10. And then divide by 5, you get x equals 2. On number 10, the first thing you should do is factor. The top one, 3x minus 6. What are they both what can you take out of them?
3.
3. If you take out a 3, you get an x minus 2. On the bottom one, whenever you see like x squared plus and minus, that's when you say parentheses x plus x minus.
Why did you put minus 2?
Because what's 6 divided by 3? You took out a 3. Okay, so here again on the bottom, x plus x minus. What two numbers multiply to give you 6 and subtract to give you a 1?
5 and 5.
5 times 1 is 6.
No.
Again, multiply to give you a 6, subtract to give you a 1. 2 and 3. And it should be 3 minus 2. 3 minus 2 is positive 1. Cancels out here. The x minus 2's. Okay, when the ones that cancel out, they're the ones that make you the wholes. Okay, that's where your holes are. So x minus 2 equal to 0, which means it'll be x equals 2. Yeah. Asymptote is the ones when they're left over in the denominator, set it equals 0. It's basically the opposite. X equals negative 3. The horizontal asymptote looks at the degree before they were factored. When the numerator degree is smaller than the denominator degree, 1 is less than 2, then you're automatically y equals 0. Okay, so that's why I said the notes on that would be very good.
Where did you get the 1 again? Where did you say 1 is less than 2? Because it
The
doesn't have
exponent is here is 1.
Oh.
You're looking at the degree.
Oh.
And then finally on the zeros, are there any x's or x factors left on the numerator, left up top? No. So there were no zeros. You have to have leftover numerator factors to have a 0. Nothing can be factored out further, but does anything cancel out top or bottom? Top and bottom?
X.
No, because the x minus 3 doesn't allow you to.
There's
Okay,
nothing
well,
in
then
So nothing cancels out. So that means since nothing cancels out, like I don't see an x minus 3 and x minus 3 to cancel them out, there are no holes. Because if nothing cancels out, there are no holes. So for my holes, none. See, you should always think of it like that when you put that. None. None.
I don't put
All right.
none, I put no.
Now, what's left over in the denominator? X minus 3. What's the opposite of that minus 3?
X plus 3.
Positive 3. But we'll go with that. Okay. Horizontal asymptote. The numerator degree is greater than the denominator degree. 2 is greater than 1.
So it's 1.
Start one of another situations. When the numerator degree is greater than the denominator, there are no horizontal asymptotes.
So none.
None. None.
And then when the denominator is greater than the
Okay. Since you have an x here in the numerator, and it's not plus or minus, it's just x equals 0. That's it. Your 0 is at x equals 0. So your 0 is at 0. Go with that. Again, remember, anytime it's like, I don't care what it says. If there's no plus or minus, it's just some number times x, or x squared or x cubed, that's x equals 0. Always. So we're going to factor this. Anytime you see squared, x squared minus a number, think plus and minus square roots. What's the square root of 25?
5.
5. So x plus 5, x minus 5. That's on top. Okay, plus plus means plus plus in the parentheses. What two numbers multiply to give you 30 add up to 11? Yep. Okay, so then we can figure out our holes and our vertical asymptotes, our horizontal asymptotes, and our zeros from that. All right, so let's start off with the holes. Are there any factors that cancel out?
Yes.
Okay, x plus 5. What's the opposite of that?
That's minus 5.
X equals negative 5. Okay. Vertical asymptotes. Are there any leftovers in the denominator, in the bottom?
Yeah. 6.
So the opposite of that?
X negative 6.
X equals negative 6. Correct. Horizontal asymptotes. Again, look back at them before they were factored. Square and square, that means they're the same. So you look at the numbers in the front. The numbers in front are 1 and 1. What's 1 divided by 1?
1.
So y is equal to 1. And then finally the zeros. What's left over in the numerator? Which is the opposite of a minus 5?
5.
There we go. Okay, so we're going to multiply by the reciprocal.
And the thing, isn't it like the two middle ones are together and then the top and bottom ones are together?
No.
Huh?
Because I saw it in the book.
Oh, yeah, that's what ends up happening.
Okay. Just making sure.
Okay, now notice here, I'm factoring the x squared minus 9 as I do this. Okay. So yeah, if you look at this, the x plus 7 that's here in the first one was on top, the x squared minus 9 was on the bottom, and notice they're multiplying together. And the two middle ones are multiplying together. Now, here though, the way this is set up, you're just trying to see what you can cancel out. What cancels out?
X plus 7 and then x minus 3.
Which leaves you with just x plus 3 as your answer. That's it. 8. Again, 7 and 8, you need a common denominator to add or subtract. So to get the common denominator, let's look at try to factor the denominator. See if you can. On the first fraction, 6 over x squared minus 1, you can factor or simplify x squared minus 1. So x squared minus means you write x plus, x minus. What's the square root of 1? 1. Okay. So now if you look at this fraction, that denominator is x plus 1 and x minus 1. The second one already has an x minus 1. What's missing?
X plus 1.
X plus 1. So you need to multiply both top and bottom of the second one by x plus 1. Now when you do that, you're just combining it all into one big fraction again. Okay? So did I have to multiply the 6 by anything? No. So I write the 6. Okay? 2 times x is 2x. 2 times 1 is 2. But the minus is going to make them both what? Negative. So I have minus 2x minus 2. All of that over x plus 1, x minus 1. And then you can combine your like terms. What's 6 minus 2?
4.
Where's the 1 in there? Oh, x minus 1. Okay, sorry. Minus 2 goes. And that's it. That's your answer. Once you've combined your like terms, that's it. You're done.
No, you raised it.
Oh, sorry.
It's alright. That was fast.
Same idea. But if you notice here, is there anything you can do to, say, further factor those? No. So all of this really is a kind of a cross multiply. The 3 is going to multiply the x plus 5, and the 4 is going to multiply the x minus 2. Even though I'm showing it a little bit differently, that's exactly what basically happens. And then the denominator is just those two denominators put together. You're basically putting the x plus 5 and the x minus 2 together in the denominator. But that means you're multiplying, like cross multiplying on top. What's 3 times x? 3 times 5? Okay. 4 times x is 4x. 4 times negative 2 is 8. And then combine your like terms. Notice again, we're doing nothing with the denominator other than putting them together. And then we're combining the numerators on top. Divide, you multiply by the reciprocal. Now, as I'm doing number 6, I'm going to go ahead and factor it. Plus minus is a plus and minus. What two numbers multiply to give you 15, subtract to give you a 2? 5 and 3. 5 times 3 is 15, 5 minus 3 is 2. Okay, nothing I can do with the 9x6y Now again, multiply by the reciprocal. You don't divide, you multiply by the reciprocal. So the 9x squared y to the fourth now moves to the top. And then what can you factor out of the 4x minus 12? You can divide out the 4. Factor out the 4. Okay. Again, now it's a multiplication problem. Make it one big fraction. And cancel out. What cancels out? X minus 3. The 9's cancel out. What do you do with the x squared and the x6? What do you do with those exponents? Subtract. You're dividing. You subtract. What's 2 minus 6? Negative 4. Okay, if it's negative, where does it go? To the bottom. Okay, the y's. 4 minus 1 is 3, and that's positive 3, so that goes on top. What's left over still? X plus 5, and you're done. Again, it's multiplication. I'm factoring, so I'm trying to set up the factors first. On the first one, I can take out the x, leave me x times x minus y. X squared minus y squared is just x plus y, x minus y. What cancels out? Okay. If you leave this as your answer, you will get it wrong, or you won't see that answer choice. I'll say you won't see the answer choice. I'll try to make it that obvious. Because you're not done. Because you can get rid of the 12 and the 18, or you can simplify that. What's 12 over 18? Simplify. If you're not sure, you type it in the calculator and you hit enter. So, there you go. That's what I would have as an answer choice. But I probably wouldn't try to make it like super obvious, or like I don't think I would give you an answer choice like this, make you think maybe I could choose that. I mean, that's what I used to get as answers, like when I did non-multiple choice, and I would count it half right. But no, I'll make it hopefully fairly obvious. But I don't know, y'all find ways to.
So you'll put the answer 2 over 3.
Yes, I would put only 2 over 3.
All right.
Yeah. Any other questions on that? Okay, then I'll get to 3 and 4 in a minute, but let's look at the.
1 and 2.
Yeah, let's look at 1 and 2. Now, 1 and 2 talk about directly and inversely. We've talked about jointly and combined also, but I probably won't get those onto the test, so you can focus on directly and inversely. Again, anytime you see the words directly, you're saying y is equal to k times x. Anytime you see inversely, you're saying y is equal to k divided by x. Okay, so again, number 1, there you should have that answer. All we did was say substitute it in, and make sure you did it by varies inverse or varies directly. Okay, number 2 says varies inversely. So as soon as you read the words varies inversely, you put y is equal to k over x. Then before it varies inversely, it says something about time. So time is the y. Then it says something about a runner's speed after varies inversely. That's your x. Plug the numbers where they go, and you kind of work from there. Varies inversely is a little bit more forgiving, though, than directly. Because you're going to still multiply those two, get your constant of variation, which is 26.195, and then put that back in. And then it says something about how long, what's the runner's speed when they take 3.5 hours to run? Well, where's the 3.5 go?
That's
26.195.
Can you ask that again?
Where does the 3.5 go?
Isn't it?
Isn't that time?
Hours, yeah.
Yeah. So that goes in place of the y. But to find x, what are you going to do with that 3.5 and the x? Really, all you do is switch them.
Multiply it.
So here you're saying x is equal to 26.195 divided by 3.5, which is 7.48. Anytime it's like this, these two just switch, and then you can divide. Here you can see 15 over 35. Type it in your calculator, press enter, you get a 3 over 7. x5 over and x2. Subtract the x1s. 5 minus 2 is x cubed. Goes on top because it's positive. 1 minus 5 is a negative 4. Since that's a negative, it goes on the bottom. Make it positive. Here on number 4, I factored, and then I saw what canceled. And whatever was left over, that's my answer.